Okay. All right. As I mentioned earlier, basically this is material for next week, for week 4. But since you need to submit your answer by tomorrow, I think better we proceed with the content of next week. And in today's session, we will have a look at examples on Supernode and Supermesh. Okay, as an overview for what we have learned so far, in the last 2 weeks, we have already covered this part, Ohm's law, Kirchhoff's law, and so on. And this week, week number 3, we have been introduced with nodal and also mesh analysis. And I will extend the knowledge of nodal analysis towards Supernode and Supermesh analysis. So this is what we're gonna have a look today. Example, I have 2 examples on Supernode and also 2 examples for Supermesh. Okay, what does it mean by Supernode? Supernode, basically, if you have a voltage source, okay, voltage source in between 2 non-reference nodes. For example, in this circuit, have a look at node V2 and also node V3. In between that node, we have a voltage source. So the way to solve this kind of circuit arrangement is by using supernode. By definition, it says here, a supernode is formed by enclosing a voltage source, either dependent or independent. In this case, this is independent voltage source connected between 2 non-referent nodes and any element connected in it with connected in parallel with it. So this is sort of circuit arrangement that we consider contain a supernode. You need to solve it using supernode analysis. I think this have been explained earlier about in this example, circuit node 2 and node 3 form a supernode. The current balance would be, okay, the current, we try to apply KCL at the supernode. Here's our supernode is node V2 and V3. So if you look at the KCL at these 2 nodes, current coming in is I1 and also I4. And current coming out is I2 and also I3. So that's why here we have I1 plus I4 equals to I2 plus I3. Basically, this one is, oh, maybe erase first. This is I in, all current coming into the supernodes V2 and V3, and this part is I out. Basically, this is the definition of Kirchhoff current law, where Kirchhoff current law says that sum of I in equals sum of I out. Okay, and we remember that for node analysis, we try to express our current in terms of voltages. So here, if you look at the next equation, this current is expressed in voltage terms. So we have for I1, we have V1 minus V2 divided by 2, V1 minus V3 divided by 4 for I4, and so on. Okay, in order for us to apply supernode or to analyze the circuit using a supernode analysis, we need to also to apply Kirchhoff voltage law. Kirchhoff voltage law is applied at the supernode. In this example, if you see that this is the supernode that we considered earlier, V2 and V3, we try to apply KVL around this loop, we try to get the equation of Kirchhoff voltage law around the supernode loop. So in this loop, you can see that we have V2, negative V2 plus 5 plus V3. So this is a complete loop for the supernode. And in general, we can say that for supernode analysis, we need to apply both KCL and also KCL. Later on, maybe you can have a look at this note. Maybe you can have a maybe you can read all the points over here. But in general, what I try to emphasize is that to apply supernodes analysis, you need both Kirchhoff current law and also Kirchhoff voltage law. And you need to focus on the supernodes, try to find what is the current coming in and coming out into the supernodes, and also the voltage developed across or encircle the supernodes in the circuit. Okay, if you look at the example over here, and we try to apply supernode analysis, someone tells me that I cannot open the lecture notes, it shows error. Maybe later on I will re-upload, but not now, because now I think I'm going to proceed with the example, the notes first. And later on, maybe you can have a look at what e-learning and try to download it back. Okay, we proceed with example number 1. If we consider this circuit, okay, looking at the circuit itself, it clearly says that these two nodes, is a non-reference node. Means that we can assign this two node with V1 and also V2. And since between V1 and V2, we have a voltage source, this is independent voltage source, we can say that, okay, this is the supernode area. Okay, this is the supernode that we would like to pay attention with. And if we get into the solution, I've already write down the main points of the solution. First, in circuit analysis, or when you try to solve your circuit, make sure you try to redraw it back so that you can get, or if you don't want to redraw it, make sure you do some sketching in the original circuit that available in the question. So make sure you do that, because what we're trying to do is we try to analyze the connection of the circuit. Here, if you look at the circuit, we already label or we already identify the supernodes area. And first of all, for node analysis, you need to assign the current direction, flowing in or flowing out from the node. But basically, for node analysis, current flowing in is basically the current source. Current flowing out, it's a current, the other branch, we can consider it as current going out. So here you can say that current going out from V1 is I1 and I2. You can also use a different direction. For example, you try to use this direction or this direction. It doesn't matter, it's okay. But remember, if you try to do that, make sure you maintain it until the end of the analysis. Otherwise, you will get confused and the solution or the analysis will be incorrect. So let's consider that the current is in this direction and in that direction, meaning that the current is going out or flowing out from V1. And at V2, you can see here, I3 is flowing out from V2, node V2, and towards the reference node or towards the ground. And also there's current, which is I4, consider flowing from V2 to V3. Okay, if you try to draw the current, or if you try to assign I4 in the opposite direction, doesn't matter, it's okay, you can do that. However, you need to maintain the current direction towards the end of the analysis the whole time. Okay, all right, let's consider the current is assigned to be like this. And we know that we have two nodes here, V1 and V2, considered as a supernode. And also we have another node, which is a V3. Why don't we consider this also a node? Because this is the same node as V1. We don't have any elements over here, so we can consider this node also as V1. Okay, and first of all, we need to apply Kirchhoff voltage law at the supernode. If you look at the supernode Kirchhoff voltage laws, here we have V1 and V2. We can also label it as positive of V1 and negative of V1. In other words, I would like to say that I can consider the supernode voltage arrangement is like this. This is V1, V2, and okay, I would say this is positive V1 and towards negative here, I have positive V2 and negative over here. And if I try to get a Kirchhoff voltage law at the supernode, means that encircle this area. So this is the KVL that we try to find, or we try to find the equation of voltage law around here, Kirchhoff voltage law. So here we have negative V1 plus, if I start from here, negative V1, I start here, okay, around the circuit and go back towards here, negative V1 plus 12 volts. And later on, we have plus V2. And all this should be equals to 0. This is a Kirchhoff voltage law around this loop, around the supernode loop. And remember that we don't care about this current source and also this voltage across 2 ohm resistor, because we already considered from this point towards the ground, it's considered as V1. So this is the Kirchhoff voltage law at the supernode. And also we need to find Kirchhoff current law at the supernode. If you look at the equation here, I have I1 plus I2 plus I3 plus I4 equals to 3. Basically, what's going on over here is, if you look at, this is considered as V1. Okay, and if you look at over here, maybe I have resistors, and maybe this is longer than that, and I have a current. This is at V1, yeah. I have 3 ampere current over here, and I have a current that I labeled as I1 previously over here, and I have I2 flowing upwards from V1. And also at the supernode, this is a supernode, right? V1. At supernode, we have another node, which is V2. Okay. I label this is as V2. I have I3 over here and I4. Okay, this is considered as our supernode area. Okay, and if you look at the Kirchhoff current law, means that you try to assess current coming in, current flowing out from the supernodes. We can say that, okay, you can write the equation as this: sum of I in equals to sum of I out. I in this case, we have I 3 ampere and normal. Okay, 3. Current coming in is 3 ampere. Current coming out is I1, I2, plus also you need to consider over here I3 because this is also the supernode, plus I4. So that's why if you look at the Kirchhoff current law at the supernode, we have I1, I2, I3, and I4. You need to consider both supernodes. All right. And again, as this is a node analysis, or in other words, we need to express our current in terms of voltage. Have a look at I1 first. So I1 here we can consider as, in terms of voltage, it is V1 divided by 4. So V1 divided by 4 is our I1. For I2 is V1 minus V3. Okay, V1 minus V3, this is the voltage difference at 8 ohm resistor. So divided by 8. So this is our I2. And earlier we have I1 over here. And for I3 is current over here. It's V1 minus 0, or sorry, not V1, V2 minus 0 divided by 2, or you can also write it as V2 divided by 2 ohm. So we have I3 over here. And finally, for I4, it's V2 minus V3 divided by 1. So I4 is V2 minus V3 divided by 1. Maybe you might wonder, just now I also suggest, I also says that if you have a different direction, for example, for I4, I have this direction for the current I4. What happened to my equation over here? Equation, okay, if you change the current direction to be that way, means that we're going to have current over here coming into V2. And for the Kirchhoff current law equation we have down here, you need to include I4 over here. Consider it as I into the supernodes. And I4, if you try to write it down in terms of voltages, I4 will be given by V3 minus V2 divided by 1. Because the current is in that direction, you see that V3 should minus V2 and divided by I1. That is if you consider the current is flowing that way. So in this example, we already label it as flowing from left to right, which is in that direction. So maybe I'll erase this first so that you're not going to get confused. As usual, after you express the current in terms of voltages, you need to simplify this and come out with the final equation. And in this example, if you see over here, we have 3 unknown variables. We have V1, V2, and also V3, three unknown variables over here. Okay. Later on, if you go carry on your analysis, what you need to do, you need to substitute I1 and I2. This is something which is what you're trying to do is you try to reduce the unknown variable. If you look at earlier, we have definition of V2 is V1 minus 12. You can easily substitute this equation into this equation so that your second equation will be reduced into two unknown variables. That depends on your creativity. Maybe you can directly substitute it, or maybe you can leave it like that towards the end. When you try to solve your equation, maybe you can substitute it later. It depends on your creativity or your math competency, whether you try to substitute it earlier or later. It's also can. Okay, what's very important over here is that if you look at the circuit itself, we have another nodes over here, which is V3. And we didn't analyze this V3 yet. And since we didn't analyze this V3 yet, it's very hard for us to analyze or to find what is the value of V3. In other words, we need to find an equation related to V3. So to find the equation related to V3, we apply KCL at node V3. If you look at node V3, okay, here I have, maybe I will draw it over here. Something which is look like this. This is I4. This is 2 ampere. And I have a current at the top coming from node 1, I believe, is I2. Okay, let me see back the diagram. So I have a current over here, I2, coming into V3. And I have this I4 from V2 coming also into V3, and I have 2 ampere coming out from V3. So 2 amperes coming out, I4 coming in, I2 is coming in. So if you try to write down the Kirchhoff current law at this node, at this V3 node, so sum of I in equals to sum of I out. I in is I4 plus I2. And I out in this case is 2 ampere. So that's how you get this equation. KCL at node V3, you need to consider the node current coming in and out at V3. And as usual, for node analysis, you need to express this current in terms of voltage. So for I2, it's V1 minus V3. Refer back here. For I2, it's V1 minus V3 divided by this 8 ohm resistor. For I4 is V2 minus V3 divided by 4 ohms resistor, 1 ohm resistor. And the other one is the current source, which is the 2 ampere. To rearrange this one, you will also end up with 3 unknown variables. However, you can simplify it towards 2 unknown variables by substituting equation number 1 earlier that we found from KVL around the supernodes. So here, what we try to do is we try to reduce the number of unknown variables. We have V1 and V3, and this equation number 5 is basically can be solved by equation number 5 can be solved by comparing with equation number 3, because both equations have two unknown variables, which is the same, V1 and V3. And again, if you try to solve these two equations, you have options. Option meaning that you can use a simple simultaneous substitution or simultaneous equation, either substitution or elimination. Also, you can use matrix, inverse matrix, Cramer rule, or inverse matrix in order for you to solve V1 and V2. And in this case, I believe it used, maybe this one is elimination, I think, using elimination. But you can try by your own. Maybe you can use substitution or you can use matrix. It's your own preference. Okay, that is for example number 1. And example number 1 says that you need to find node voltages using node analysis. Node voltages mean we have V1, V2, and V3. If you look at the example over here, towards the end, we have V1, V2, and V3. All voltages has been calculated or has been found. Okay, that's for example number 1. For example number 2, again, this is also a supernode example where you need to apply supernode in a way to analyze the circuit or in a way to find the parameters in the circuit. In this case, we need to find what is the current over here, which is I/O. And looking at the circuit itself, we can say that these two nodes is a non-reference node. Non-reference means that it is not connected towards the ground. And in between these two nodes, we have a voltage supply or a voltage source, which is, in this case is independent voltage source. So this independent voltage source with these two nodes between the voltages in between these two non-reference nodes, we can say that this part is the supernode area. Okay, this is the supernode area. And in order to apply supernode, we need to apply both KCL and also KVL, right? Okay, this is a solution for the example. As usual, we need to redraw the circuit, or maybe you can put some notes on the original circuit. In other words, I would like to try to say that we need to assign the current. Okay, assign the current. If you look at the question earlier, we don't have any current assignment over here except for this I/O. I/O, we need to find which the direction is towards the negative terminal over here. And we don't have any other current is assigned in the circuit, was assigned in the circuit. So here, let's say we assign I1 to be in that direction, I2 in that direction. We have I/O, we keep the I/O in that direction, and I3, and also I4. And we know that this is where the supernode located. And looking at the circuit, we have three nodes over here. We have V1, V2, V3, and finally V4. Not 3, basically it's 4. Sorry, that's my mistake. It should be 4. Okay. These 4 nodes is considered as a non-reference node. Means that it's not connected towards the ground or towards the reference node. Or we cannot consider this is a 0 node. This is reference node. Yeah, for reference node, we can consider it as 0 or negative bound. And if you have a look at the non-reference node, we can say that, okay, this is the positive side, negative, this should be a positive, negative, and this is a positive and negative, right? And as well as for V2, we have a positive over here and somewhere maybe try to connect it towards the negative side. Basically, it's directly, this is the highest potential of V2. Okay, for V1 and V3, looking at the circuit, it is directly connected to a voltage source over here. We have 6-volt voltage source and 4 volts. However, for 6 volts, it's arranged in the opposite direction. So here we have V1 can be considered as negative 6 volt. Means that from this point towards this point is considered as negative 6 volt. And for V3, okay, V3 we have a 4 volts voltage source is connected directly to it. So we can consider from this point or from this V3 positive terminal towards this reference node is considered as 4 volts. So we have two definitions over here. V1 equals to negative 6 volt, V3 equals to 4 volts. And we already know that these two nodes is considered a supernode. So we try to find a voltage equation at the supernode. Basically, what we try to do over here is we try to get the Kirchhoff voltage law around this area. So now, looking at the supernode area, we have voltage source, VPO, and this is P2. And earlier, we know that this is a positive band of VO, and maybe somewhere around here is negative band. This is positive band and negative band of V2. And we try to find a Kirchhoff voltage law around this loop. And if I start over here and go around the loop and go back, return to the original spot, I would have V negative VO minus 3 volts plus P2 equals to 0 as my Kirchhoff voltage law around this loop. So if you look at this equation and this equation, basically it is the same. So we can say that if you rearrange this equation, you will get this equation. Okay, but in order for you to know how did we get this equation, basically it is based on this circuit arrangement or based on this consideration. We consider this is the supernode and this is a positive side of VO, positive side of V2, and negative side could be anywhere. It's a reference. And we try to get a voltage around the loop. And if you start from here, you will get negative VO minus 3 volts, this is 3 volts, plus V2 equals to 0. And that's how we get this first and second equation. All right, for the rest of the solution, what we try to do is we try to apply KCL at the supernode. If you look at the supernode based on this circuit arrangement, maybe I'll try to draw it over here. Later on, you can have a look back at the, we try to look back at the question. Okay, at the supernode, okay, let's say this is V2 and I have I2 over here and I have I4. Okay, the direction of current I've labeled, oh, this should be I4. I labeled here already been assigned at the beginning of our analysis. Okay, for V0 or VO, oops, cannot be like this. Should be a straight line, not that straight. Okay, this is the current of I3. Okay, this is V0 lah. V0 over here. And I1 is here. This is the original IO that we try to find. Okay, go back to the question. At V2, I have I2 here and I4 over here. Okay, that's why I draw this straight line and we have two currents flowing out from V2. For this point, at this point, I have I1 coming into and I3 flowing out, and I also have IO. Okay, looking at our earlier sketch, we have, okay, I3 going out, I1 going in, IO going out, V2, I2, and I4 going out from V2. So from these two circuit arrangement, or from these 2 points, we try to get the Kirchhoff current law. So here, Kirchhoff current law given by I in, sum of I in equals to sum of I out. Okay, what is I in this case? I in this case is only I1. Okay, so I have I1 equals, I out is the rest of the currents. I have I2 plus I3 plus I4 plus IO. So looking at this equation, basically it is the same equation you found over here, except that this equation has been rearranged, but where we try to bring this I1 towards the opposite bend or opposite side. So in this case, I have I1 equals to I2 plus I3 plus I4 plus IO. Here we have I2 plus I4 plus IO plus I3 minus I1 equals to 0. Basically, these two equations are the same. Okay, and later on, we need to write down our current equation in terms of voltages. And I've already mentioned how to get I1, the current in terms of voltage in earlier example. I think I will skip that one. Maybe you can have a look later on. Okay, I just want to highlight one current. For example, I choose, in this case, I have I4. For example, I4. Okay, I4 here. Okay, looking at the original question, I4 is over here, and the direction of a current is from V2 to V3, means that for I4, I should have V2 minus V3 divided by 3 kilo ohm. So that's why here I4 is V2 minus V3 divided by 3 kilo ohm. and you can also have a look at I0, I3, and I1 later on. Okay, after you're done with expressing the current in terms of voltages, what you need to do is you need to simplify it. And after you simplify it, at the end, by uh, substituting the definition that we found earlier, at the end you will have an equation. In this case, we have equation with two unknown variable, which is V2 and V0. This is after we substitute this V1 and V3 that we defined earlier. So it depends on your creativity. How do you want to solve it? Because from this point towards the end, towards this point, basically it depends on your mathematic or level of your understanding in terms of simplifying an equation. Means that your mathematics lah. If your mathematics is quite good or quite strong, it's just as easy as ABC task lah. If you think that this is something which is how we get to that means that you need to try to work on this example later on. But basically, this is not a rocket science. It's not that difficult. You can follow it step by step. Later on, towards the end, you will get this equation. And if you look at this equation, we have two unknown variables. And basically, earlier, we already know that using Kirchhoff voltage law, we can define V2 as this equation or V0 as this equation. So here, what you need to do, just substitute. Either you can substitute V2 or you can substitute V0 in order for you to solve this equation. In this example, you don't need to use a difficult matrix inverse or Kramer rule, because it's just a simple substitution. However, you need to plan your solution. Okay, let me tell you, the electric or electronic knowledge over here is just about the supernode analysis. It's just about try to set up a Kirchhoff current law, try to set up a Kirchhoff voltage law. That is all about the electric part, electronic or electric part. The others are, it's all about mathematics. So if you want to be a very good engineer in either electrical or in terms of mechanical engineers, your mathematics should be strong. So please remember that. All right, that's two examples of Supernode. Any questions so far? Any questions so far? Easy, yeah. As easy as ABC, right? It's okay, it's okay. Just enjoy. This is maybe this is something new for you guys, but you need to don't take it too hard. I mean, if you think it is hard, means that it's gonna be hard. Okay, you need to have a belief in yourself, but don't overconfident lah. You need to have a belief that you can do this, but this with practice lah. If you don't practice and you think that I can do this, bye bye lah. Okay, let's take 5. I think maybe we start again at 11:55. Oh, welcome back, everyone. It's already 11:57. All right, and welcome back, everyone, for the second part of our lesson. This is basically I want to give advice lah. Basically, what I've delivered here is not enough. What you need to do is you need to have more exercise. You need to do more exercise, or otherwise, basically you plan to get fail lah in this subject, because it's never a shortcut to be or to score good marks in this course, because based on previous record, basically this is a killer subject in your first semester, and you need to work hard on this. I mean, you need to get or you need to do more exercise lah. Otherwise, you're never gonna get the full understanding or the knowledge of this course, the topics inside this course. It's very essential lesson or essential topics that are taught in this course. So this is not like your A level or your diploma studies where everything gonna be spoon fed. So I just trigger the knowledge. You need to find yourself and master it yourself, because this is a degree level. You need to work hard lah, in other words. Okay, that's sort of maybe advice maybe for me. Okay, we would like to continue our lesson. Now, we move on into another analysis, circuit analysis. In this time, we try to have a look at Supermesh. In general, Supermesh happen when you have a current source in between two meshes. If you look at this circuit arrangement, you have two meshes. First mesh is over here, and second is here. And in between these two meshes, you have a current source over here. So in this situation, we can consider this circuit must be analyzed using Supermesh. And looking at the circuit arrangement, you need, when you try to apply Supermesh, you need to apply both KCL and also KVL. And for mesh analysis, if you remember from previous class, in mesh analysis, we try to set up a Kirchhoff voltage law around each mesh. So here, what we try to do is we're still gonna set up a Kirchhoff voltage law around meshes, and also you need to consider Kirchhoff current law at the Supermesh. Okay, maybe later on you can read all this because I've already explained the general part of Supermesh, how the Supermesh happen. This is the circuit arrangement that you should consider a Supermesh analysis, and it is because of this current source, either dependent or independent current source. In this case, it is independent current source in between two meshes. All right. Also, you need to merge the meshes to become one mesh over here. Maybe if I have a look, I show you the example, maybe you can have better idea on how to analyze a circuit using Supermesh. Okay. still from the example circuit that I showed earlier, that first of all, you need to apply KVL around the Supermesh. If you look at the circuit, you have a current source in between these two meshes. So in between these two meshes, there is a current source, means that we have a Supermesh. And then what we're trying to do, we try to combine these two meshes to become like this. So once you combine, you will try to set up a Kirchhoff voltage law around the Supermesh. So in this case, for example, if I have a current over here, first of all, I will start by doing labeling the polarity of my voltage drop at each of the resistors inside the Supermesh. So if I apply, if I assign the polarities, this is the polarities of the voltage drop around the mesh. And if I start my loop from here, go around the Supermesh and return back to the original place where I start, I will have an equation or Kirchhoff voltage law equation as -20 plus voltage across here plus voltage across here plus voltage across here and equals to 0. In other words, I would say that I would have -20 plus 6 ohm times I1, because if you look at the original circuit, this is the meshes for I1, current over here is I1, and then I have plus 10 times I2. Looking at this resistor, it's over here, so current flowing through the resistor is considered as I2, and plus 4 times also I2, because current over here is I2 and equals to 0. Okay, if you look at this equation and compare it with this equation, basically it is the same equation. And also, if you compare it with this equation, it is also the same equation. This equation means that we already simplified the original Kirchhoff voltage law equation. And later on, you need to apply KCL. KCL at the supernode means that this is the supernode. So you need to consider the KCL, or you need to consider this node and look at its current coming in and current coming out from that node. So here, okay, for example, yeah, if I have this one labeled as X and this one is I1 and this is I2, and I have current coming in, which is 6 ampere. Okay, maybe you were wondering what happened to these 2 ohm resistor. I just neglect it because it is the same current flowing through this line or this branch and towards the X node or the super node. So from this definition, I would say that current coming in or sum of I in is only this part, okay, I1, not only that part, I1 and also I2. 6 ampere. This is current coming in. And current out. Current out is I2. So that's how you get this equation. I2 is equals to I1 plus I6, I1 plus 6 ampere. And looking at the two equations that we got earlier, basically we can solve this first equation because we know what is the definition of I2. So when you substitute this I2 inside this equation, you can find both answer for I1 and I2. So that's basically the idea of Supermesh analysis. When you try to solve a circuit using a Supermesh, you need to apply both KCL and also KVL at the Supermesh. Look at this example. Looking at this example, you know that we have three meshes. This is the first mesh, second, and the third mesh. Okay, 1, 2, and 3. Okay. Between loop number 2 and loop number 3, we have a current source over here. Means that this should be considered as a super mesh. Okay. And also, this is the node where you need to pay attention, or you need to set up a KCL at this node. So looking at the solution, you have three meshes, number 1, 2, and 3, and label it as I1, I2, and I3. First of all, you need to apply KVL in mesh number 1. Since this is a mesh analysis, means that we try to apply KVL. And KVL at mesh number 1. So mesh number 1 basically consists of this resistor, 1 kilo ohm, 3 kilo ohm, and also 6 volt. And current is flowing this way. Remember, once you set your current is flowing in that direction, keep it constant, keep it that way. Don't try to change the direction of the current. So this is considered as I1. And looking at the loop, we're gonna have voltage polarities, voltage drop polarities to be like this. Maybe I'll change the color. This is 1 kilo. This is 3 kilo. And this is 6 volt. Setting up the equation, if I start from here, okay, let's say I start from here and go around the loop and return back to here in that direction, okay, I have 6 equals to, sorry, not 6 equals to, delete. First, I have 6 volts plus 1K times I1 and go on towards the next voltage drop is plus 3K times I1. And this is equals to 0. So this equation, basically, it is the same equation you found over here. And if you look at the equation itself, we have only one unknown variable, which is I1. So you can straightforward get the value of I1 over here, which is negative 1.5 milliampere in this example. And that is for mesh number 1. For mesh number 2 and number 3, earlier we know that these two meshes is a super mesh, can be considered as super mesh. So first of all, you need to apply KVL around the super mesh. To apply the KVL around the super mesh, you need to consider a circuit which is look like this. Okay, I have 6 over here. I have 3K. Maybe my drawing is not that good. If I have a whiteboard over here, then it should be okay. Maybe I'll try to use pen. I don't like to use this pen because very annoying using this one. 1 kilo. Wow, see? Very annoying. 1 kilo over here. And I have not 1 kilo, 2 kilos. Should be 2 kilos. Sorry. 2 kilo. And I have 4 kilo ohm over here. 4 kilo ohm means that 4,000 ohms. This is also 3,000 ohm, and this is also 2,000 ohm. And this is the super mesh that I would like to highlight, where you know that if we have a current flowing through here and also through here, we do have a voltage drop across these 3 resistors. And looking at the current, basically current flowing into this resistor is considered as I2, and current flowing through this resistor is considered as I3, and at this resistor also I3. Okay. And to get the Kirchhoff voltage law around this loop, okay, around this loop, let's say I start from here and go around the loop and return back here. I have negative 6 plus 3I2 3K I2. I have plus 2K I3 and plus 4K I3, and finally return back to the original port. I have equals it into 0. So if you look at this equation, basically it's the same equation you find it over here. Maybe this lah. Okay. This equation basically can be found over here, and this equation is coming from this kind of circuit arrangement for super mesh at mesh number 2 and mesh number 3. And if you rearrange that equation, you will end up with these 2 unknown variables. I have I2 and I3. And to get the value, or to evaluate the value of I2 and I3, first I need to apply Kirchhoff current law at this super mesh node. Okay, at that node, if you look at that B node, B, I have a current here is SI3, the current over here as I2, and current coming in is 2 milliampere. And if you analyze the Kirchhoff current law, sum of I in equals to sum of I out. I in is basically I2 plus 2 milli and equals to I out is I3. Okay, and this is considering Kirchhoff current law says that I in equals to sum of I out. Sum of I in is I2 and 2 milliampere, and I out is I3. Sorry, I out is I3. And looking at this equation, basically it's the same. You look over here. And for the rest of the solution, basically what you need to do is you need to substitute, or you need to solve the simultaneous equation. You already had the definition of maybe I3. If you substitute I3 into the first equation, maybe you can get I2. Over here, I have 3k I2 plus 6k I3 equals to 6. Here I have I3 equals to 2 plus 2 milliampere, I2 plus 2 milliampere. You can substitute this equation into this equation to get I2, or maybe you can rearrange this one. Maybe I2 equals to I3 minus 2 milliampere and substitute inside this equation. And the rest should be the mathematics. The way you solve depends on your preference. Okay, once you get I2 and I3, okay, return back to the question. Question says that you need to determine the current in each mesh and the current supplied by the voltage source. Okay. Current supplied by the voltage source is over here. There's only one voltage source in the circuit. Current supplied means that current coming out from the voltage source. You need to find what is the current over here. Let's say I put it as Ix. Okay. You need to find the current here, and to get the current, the value of current over here, what you need to do, you need to have a look at this junction, or try to apply this junction. So this is Ix, and earlier we have I1 over here and I2 right here. Based on Kirchhoff current law, it says that sum of I in equals to sum of I out. And I in is I1 plus Ix. I out is, in this case, is I2. So if you try to find Ix, it's basically given by I2 minus I1. Since you already know the value of I2 and I1 in your calculation earlier, so you just substitute it back into here, and towards the end you will get the answer of a current. And make sure this the direction of a current over here is correct, because in the question it says that current supplied by the voltage source, means that current being supplied by this source means current going out. Okay, going out. So the direction is like this. You need to carefully read the question. All right, that's for example number 1. Example number 2. Example number 2, the question basically asking about power dissipated in 1 ohm resistor. Sorry, 100 ohm resistor. 100 ohm resistor is over here. In a way to determine the power dissipated, you can, for the power, you can use these three options. V times I, or you can use I squared times R, or you can use V squared over R. Okay, the R value over here and here is 100 ohm. Okay. The I current here is a current going through here. The voltage stated over here is the voltage across this resistor. So in other words, if you try to find the power, what you need to do, you need to find first what is the voltage and the current over here, or the current over here. If you get both quantities, voltage and current, you can always apply this equation to get the power dissipated across, or power dissipated in this resistor. Okay, that's the idea. However, if you look at the circuit, if this is mesh number 1, mesh number 2, and mesh number 3, mesh number 1 and mesh number 2, in between these two meshes, we have this current source. Means that we need to apply Supermesh. Okay. The way to apply Supermesh is to consider this is the Supermesh loop. Okay, the first is the Supermesh loop. This is 240. This is 100. And the other one is try to analyze this node. Okay, let's say I put it as X. X over here is defined by I1. This side we have I2 and current coming in, which is 4 ampere. So you need to consider these two definition. First is the circuit around the Supermesh, and the second one is the nodes at the Supermesh. Okay, the solution. First, you try to redraw, or you can get from the original circuit, and you already identify where is the Supermesh, and you already assign, or you already also identify the mesh I1, I2, and I3, 3 meshes, and look at the first definition here, mesh number 3. Mesh number 3, okay, if you look at this mesh number 3 consists of current source, okay, maybe my drawing is not that good, but it's just a sketch. Okay, this is the mesh, and we have 2 ampere current source over here. Means that whatever current we consider in mesh number 3 is basically the value is 2 ampere. So that's why here we see that for mesh number 3, I3 equals to 2 ampere because we know that the current flowing through here is 2 ampere, and for the current flowing through here or here is not 2 ampere, but the mesh itself is 2 ampere. So I3, this is I3, is 2 ampere. And then you try to apply KVL in the supermesh. KVL in the supermesh, looking at the supermesh, which is this side, this one, this one, this one. Maybe I'll remove this first. This one. Okay, the green line, yeah. Okay, looking at this loop, first of all, what you need to do, you need to determine the polarity of the voltage drop across each resistor. Here we have 240 ohm. Since there's a current over here flowing through here, this part or this side should be a positive. And since we are considering current flowing in that direction, means that there is a current over here, and this side should be a positive terminal as well. And when you try to work out the equation for Kirchhoff voltage law for the supermesh, let's say I'll start here and around the supermesh and return back to the original point. I have negative 12 plus 240 times I1, okay, minus 10. Why minus? Because this is a minus sign. So when I going through this way, this loop, first negative 12, positive, negative 10, and later on I have a positive 100 times I. Why I put I? Why not I put I2? Because if you look at this junction or at this current, basically coming from this junction, looking at that junction, this one is considered as I2. And this one is considered as I3. This I, current over here, is basically the combination of both I2 and I3. And looking at that junction, this is the current I2, and I3. I is basically given by I2 minus I3. And how does this happen? It is happen because if you find the current coming in and current coming out at this point, okay, at that point, current coming in is I2 and current coming out is I3 and plus I. Okay. This is Kirchhoff current law. Current in equals to sum of current out. When I rearrange or I put this I3 towards the left hand side, so I can get I equals to I2 minus I3. So this current 100 should be times with I2 minus I3. And around the loop, back to my original place where I start. So equals to 0. So this equation, looking at this equation, it is the same as what you found over here. You have negative 12 plus 240 I1 minus 10 plus 100 times I2 minus I3. And when you try to simplify that equation, you will end up with these three unknown variables, I1, I2, and I3. And remember, for Supermesh, we also need to apply KCL. And this KCL, we are looking at this point or at X. Okay. Looking at X, you have I1, you have I2 is over here, and finally I have current I4, which is the current source. And solving or set up the Kirchhoff current law, sum of I in equals to sum of I out. I in this case is I1 plus I4, and I out is I2. So that is how you get this equation. Okay, if you look at both equations, if I substitute this I2 inside here, I will reduce this equation into two unknown variables. Still not enough. However, looking at the first one here, I3, and if I substitute this I3 inside this equation, I can simply reduce it into one unknown variable, and I can find the value of I1 easily by doing that. So first, you need to put in the I2, or maybe first you can put I3 inside here and also I2 inside here, and you can solve for the I1. Right. Here is the solution that I mentioned earlier, where I put I2 and I3 over here, and I will get the value of I1 easily. And return back to the equation that we have, we can also get I2 since we have already have I1 over here. And for the current flowing through this 100 ohm resistor, basically it's coming from I or I2 minus I3. Since I2, we already get it from here. I3, earlier we have already defined it as 2 ampere. 2 ampere, then we can easily get the value of current over here. And for the power dissipated, you can always use I squared R, V squared over R, or V times I. But in this case, if you want to make it faster, maybe you can use I squared times R, because you already have the current over here, and straightforward you can get the power dissipated. And remember that this P, the P power, if you try to calculate power, the value always a positive value, because we have I squared R. If the current here is negative and we square it, we will get a positive value. If the voltage, let's say we have V squared over R, we're using V squared over R. V is a voltage across here. Okay. Voltage across here is V. If the voltage is negative as well, you can, if you square it, you will get a positive value. Okay. Any questions so far? I have shown you two examples of Supermesh and also Supernodes in our first part. Okay, this is the recap of what we have learned from Supermesh, and also not from Supermesh, from Node, Mesh, and also Supernode and Supermesh. You need to know that there are two types of circuit analysis method. First, by using node. The second one is by using mesh. Normally, if you try to apply node analysis, you will see that the circuit have many parallel connected elements. So that's why I show over here, when you have many parallel connected elements, nodal is the best way lah to analyze your circuit. Doesn't matter whether you're gonna try to find voltage or current and so or others. And if you have a many series connected element, you try to use mesh. Okay. However, if the question specifically says that you need to use mesh analysis or you need to use node analysis, means that you need to apply that particular circuit analysis method. You cannot use other, because it depends on the question being given to you. And also, in nodal analysis, we have supernodes, and mesh analysis, we have supermesh. And in general, we can say that node analysis is the most fundamental analysis method, where we try to use node, try to work out the Kirchhoff current law around that node, and later on find the expression of the current based on the voltage. However, you can basically apply both either node or mesh analysis in order for you to solve your circuit, in order to find the value of, for example, power dissipated, maybe current, maybe voltages at a particular resistor. You can use any analysis method. But remember, please pay attention at the question given to you. If the question specifically asks about node analysis, means you need to apply node. If specifically apply mesh, asking about mesh analysis, you need to apply mesh analysis. So you don't get too excited, because you can say, yeah, I can use any analysis, yeah, but the question says you need to apply node or mesh analysis to solve it. You can use your own preference to check your answer. Maybe if the question asking about node analysis, maybe you can check your answer later on using mesh analysis. Make sure your calculation or your analysis is correct. Okay. I think that's all for today. Next topic, we will get into the circuit theorem. The most famous circuit theorem is known as Thevenin and Norton. But before we learn about Thevenin and Norton, we need to get to know another way to analyze our circuit by using a theorem known as superposition and also source transformation. Maybe these two theorems, superposition and source transformation, it's a bit easier to understand. It's not like Supermesh and also mesh nodes analysis, because node analysis, you need to apply a simultaneous equation. You need to set up an equation for these two theorems, superposition and source transformation. You will automatically get the value of the desired element that you try to analyze. Okay, as usual, please do some pre-reading about this topic, because I don't want you guys to get like 0 when you enter the class, because if you like just don't have a pre-reading on that particular topic, maybe you don't have idea about what's going on. Maybe it's quite difficult for you to understand the content of the lecture. Okay, and remember, next Friday, not next Friday, tomorrow is the deadline for your homework submission. Your homework submission, I think I have already put the answer for the homework. Maybe you can check your answer with the value that I gave in the question. For the solution, okay, for the solution activity week number 2, I will post it in e-learning. Maybe later on you can have a look at the solution, and also solution for this week 3 activity, I will post it next week. I think that's all from me today. Maybe you can we will see again next week on Tuesday 9 a.m. And before we leave, I need to